Solving radical equations. Today we're going to talk about what does it mean to solve a radical equation? How do we undo a square root? We're looking at solving with one radical, and really important, you always want to make sure you check your answers to make sure they work. Let's get ready. You're going to need your notebook, pencil, and calculator. And let's just think about squaring first. We've been working with square roots for a while. So when you're trying to answer these, you're thinking about what number times itself is 25. Well, that would be 5. We say that 25 is a perfect square. It's the square of 5. So if I squared 5, I'm going to get 25, and you can see that this is just a circle. So the square root of 36, what number times itself is 36? That would be 6. What number times itself is 49? And that would be 7. Again, those are all perfect squares. What if we write it differently and we think about unsquaring? So what number square rooted is 5? What number square rooted is 5? That would be 25. And that would be 36. And that would be 49. So we could just kind of ask ourselves that question and get past, but there might be an easier way, because I don't know what number times, I don't know 11 squared off the top of my head, so I have to think about that. But if we undo math, we are using inverses, and you've been using inverses all along. If you have x plus 3 equals 5 and you want to undo that plus 3, you subtract 3 from both sides and you get 2, because addition and subtraction are inverses of each other. You use them to undo each other. The same way multiplication and division are inverses of each other. If I have 2x equals 10 and I want to get to the x, I want to undo the 2. It is being multiplied, so I divide both sides by 2 and I get 5. So multiplication and division are inverses of each other. And now we're going to find out today that when something is squared and something is square rooted, they are going to complete that circle. They're going to undo each other. So if I'm trying to think about what number square rooted is 11, I have a square root here. I want to do the opposite, and I want to square both sides. Squaring a square root is going to undo it, and on the left side I get x. And now I have x by itself, which is what we're trying to do. On your calculator, you do 11 squared and you get 121. So when you're trying to solve, we're probably going to have some other numbers there. You always need to make sure you isolate the radical sign, which means you get it all by itself first by undoing the other math. So in example G, we have to undo the 3. In example H, we have to undo the 5. In example I, we somehow have to get to that minus 2, which is under the radical. So that one's a little bit different. So I want to undo the 3, so I'm going to subtract 3 from both sides. I have the square root of x equals 4. Now I want to undo that square root, so I'm going to square both sides, and x equals 16. I can check my work by plugging it back into the original, and I have 3 plus the square root of 16, which is 4, and that does in fact equal 7, so that work checks. In H, I have 5 being multiplied by my square root, so I want to undo the opposite of multiplication is division. So I'm going to divide both sides by 5, and I get the square root of x equals 9. I want to undo my square root, so I'm going to square both sides, and I get x to be 81. And on our last one, you can see the minus 2 is under the radical, a little bit different, but the entire left side is a radical. So right off the bat, we can start with squaring that left side and squaring the right side. Remember, whatever you do to one side, you have to do to the other to keep them balanced. So on the left, the square and the square root undo each other, and I end up with what's inside, x minus 2. On the right, 6 squared is 36. One more step, I'm going to add 2, and x here is going to be 38. Go ahead and pause and try these on your own. In J, I'm going to subtract 6 from both sides, so I get the square root of x equals 4. I'm going to square both sides, so I get x equals 16. On K, I need to undo the 9, so I'm going to divide both sides by 9, and I get the square root of x equals 3. I square both sides, and I get x equals 9. And on the last one, I'm going to start by squaring both sides. When I square the left, I get x plus 4. When I square the right, I get 25. I'm going to subtract the 4, and I get x to be 21. All right, let's kick it up a notch. We'll throw some more numbers in there. We've got a lot going on here. Here's my radical that I need to get by itself. So I'm going to undo the minus 17. I'm going to add 17 to both sides. So I have my square root of 3x plus 40 equals 5. Now the square root is all by itself, so I'm going to square both sides. And again, squaring and square rooting undo each other, so I get that. 3x plus 40 equals 25. I'm going to subtract 40 from both sides. 3x equals negative 15. Divide by 3, and x is negative 5. I'm going to check my work. I'm going to plug it into my original. 3 times negative 5 plus 40. And when I do that, I get negative 15 plus 40, which is the square root of 25, which is 5 minus 17. And that does really equal negative 12. So that one works. And let's try this one. I put 2 alerts here. Notice on the right-hand side, when we're going to square this, we square the entire thing. We are squaring the binomial. That means 2 sets of parentheses, and then also have to check our work. So we're going to start by squaring both sides. I'm going to show you what you can't do. You can't square this left and then square the x and square that. You can't do that. So we're going to erase that because we don't want to do that. So I'm going to square the entire sides, not the parts. So when I square the left, I get 17 minus 4x. When I square the right, I need to write out 2 sets of parentheses. We've done this before. It's a big distributive property, so I'm going to do x times x and get x squared, x times negative 3 and get negative 3x. Then I do negative 3 times x and get another negative 3x. Negative 3 times negative 3 is positive 9. On the right, I'm going to combine like terms. And let's just pause and look at what we have. Look, we have an x squared. So this is a quadratic. We're back to solving quadratics. If I'm going to solve a quadratic, I want to put it in standard form, set it equal to 0. So I'm going to move all this stuff over by adding the opposite. So I'm going to add 4 and get negative 2. I'm going to subtract the 17 and get negative 8. This one does look factorable, so I'm going to try that. I'm going to do what multiplies to negative 8 and adds to negative 2. And that's going to be a negative 4 and a positive 2. My a is 1, so I can go right to my parentheses. X minus 4, x plus 2 equals 0. Set each of those equal to 0 and solve. And we get those 2 answers, but we have to check our work, check your work, check your work. I'm going to start with a negative 2. So if I plug in 17 minus 4 times negative 2 and do the square root, and on the right-hand side, negative 2 minus 3. So here I have 17 plus 8. 17 plus 8 square root, that's going to be square root of 25, which is 5. But on the right-hand side, I have negative 5. 5 does not equal negative 5. So I have to reject negative 2. We reject that. That is not a solution. And then when I try 4, 17 minus 4 times 4, well, that's going to be the square root of 1, which is 1, and 4 minus 3 is 1. So 4 does work. So the only answer here is 4. So to recap, get the radical by itself, undo a square root by squaring both sides, square binomials correctly. Remember, it's going to be 2 sets of parentheses, and always check your answers to make sure they work. Nice job.